Hi, hello everyone. Thank you for joining me today in the Women on Stage conference. In my talk, we will learn about the story of ReasonML, or maybe the story of the future of web. Well, we don't know for sure, at least I don't know, but I will share from my experience, and in about 15 minutes, we will know a bit more. So, hi, I'm Sara Hillel. I'm a software engineer and digital nomad. I work at Walnut, where we make great demos for great companies. Before that, I worked as a freelancer for 5 years. So for most of my career, I work with early stage startups in which you have to make so many decisions with an enormous impact. It starts from the very beginning with questions such as, how do you even decide on the stack? It's hard. In recent years, it has become even harder. You have so many options to choose from. But how do we know? What will work for us? What will make our code maintainable? What will make our work fun and productive? I've noticed that modern web technologies are evolving towards four simultaneous trends. The first one is easy. There is no paradigm shift here. For the browser, JavaScript is a standard. Always bet on JavaScript seems to be accurate for the near future, whether you like it or not. The second trend, static typing. More than ever before, developers want statically typed systems. One tool that has kept shining over the years is React. For those who don't know, React is a declarative, efficient, and flexible JavaScript library for building user interfaces. And it's popular, very popular. When I try to explain its popularity, I think about how it makes me code. And for me, React is like a pit of success where it's easy to do the right things and annoying, but not impossible to do the wrong things. Let's try and see it in code. React is component-based. This is component. You build encapsulated components that manage their own state, then compose them to make complex UIs. Components can receive inputs, props. Props are immutable. You can read them, but you cannot change them. Granting immutability prevents side effects, which makes your code more predictable, simpler to understand, and easier to debug. Composing components give you a hierarchy, which facilitates unidirectional data flow. Composition, immutability, unidirectional data flows are all functional techniques that make you reason about your code. Which brings us to our third trend, functional programming. We've reached the last one, a concept which attracts many developers and companies. Learn once, write anywhere. Web, mobile, desktop. So what have we got so far? We've got JavaScript with patches. A patch for static typing, a patch for immutability, a patch for functional programming. You find yourself bike shedding with configuration and endlessly adding and learning libraries. Is there any other way to do this? Why not just focusing on code? Well, meet ReasonML. We'll jump right into the code. This looks familiar, right? It is exactly the same React code we've just seen, but now it's written in ReasonML. You might ask, where are all the types? Great questions. We don't see them here. And that's the beauty of ReasonML. It has a sophisticated type inference system. what is ReasonML? ReasonML, or Reason, was created by the same guy who created React at Facebook. Is it a new language? No, ReasonML is not a new language. It's a new syntax for the established OCaml language, but is meant to be familiar to JavaScript developers. So basically, ReasonML is OCaml with JavaScript syntax, and both Reason and OCaml can be compiled to JavaScript with BuckleScript, a super fast compiler. You may be wondering what an L stands for. Clearly not machine learning, right? Maybe for OCaml? Close enough. ML is an abbreviation for meta language, which is a functional programming language. It might be known for you from your academic studies, and it's best known for its use of the Hindley-Milner type system, which automatically assigns the types of most expression without requiring explicit type annotation. And we've just seen it in the code with type inference. Today, there are several languages in the ML family. OCaml is just one of them. So let's talk a bit about OCaml. OCaml is a battle-tested functional programming language with more than 20 years of type theory. OCaml defaults to immutable and functional code, but allows escape hatches into imperative code when you need it. As we said, ReasonML and OCaml has the exact same AST. They only differ by syntax, and both can be compiled to JavaScript directly in the browser with BuckleScript, to native code or bytecode. Alternatively, you can use the new REST which is rebranded ReasonML with BuckleScript altogether. Let's have a look in some of the language gems that might be unfamiliar for JavaScript developers. One small but odd thing you might see here is the tilde. This is for label arguments or named arguments. But the main feature in this slide is variant. Variant is data structure that enables you to choose from a variety of options. So in our case, topic can be either front-end or back-end or data. All are called variant constructors. The bar separates between them. Variant constructors can hold extra data. For example, here, the front-end topic can store the language name, a string. In our case, it might be ReasonML. When you combine pattern matching with variants, you get a powerful combination that lets you execute some code based on the shape of the data. So here, we avoided messy if-elses, and we get a clean results based on the values. Now, what happens if we miss a value? When we fail to handle every scenario, like here. So we have a compile exhaustiveness check, which will save us from this bug. And it's pretty expressive. You can understand very easily that we miss the data constructor here. We are close to end, and I'm sure you have more questions than you had before the beginning of this talk. Things like, is it ready for production? Do you recommend it? Is it hard to learn? I want to tell you about two real-world use cases, and I hope it will address some of the questions, or at least will make you curious enough to explore more on your own. The first use case is of the Messenger app by Facebook. They released some statistic in 2017-18 after factoring 50% of the Messenger app to ReasonML. They reviewed parameters regarding quality of code and developer experience. And the numbers are mind-blowing. For example, instead of getting bugs reports on a daily basis, we're now getting 10 bugs. Not per week, not per month, per year. We also significantly reduce the refactoring time and build time. So this is how ReasonML worked for a big company. Our next use case is ours at Walnut. I have no references since we start with Reason from the beginning, but I can say we have a great onboarding process where anyone who joins us without any prior knowledge of ReasonML or the codebase is able to push to production in just a few days and to make wider factoring in the first few weeks. The trust and confidence we have in the code is part of this success. That's it. In case you're curious and want to explore more, here you can find some links that can be useful. You can play with Reason on the browser. You can join the great community on Discord. You can read about it, you can start a new project, or even you can add Reason in your existing JavaScript codebase. Feel free to contact me. You can find me at Sara Hillel on most platforms. I hope you enjoy it. Thank you very much.